What is up, yo? I wanted to make a quick trig review video. I don't know how quick it's going to be actually. Plus, I will say if you were in the class when we went over trig, and I know some of you weren't, you know how long it took. It took a week or so to go through trig. A 10-minute video is not exactly going to teach you everything you need to know unless you're super quick on the uptake. So I would say reach out to me. Maybe I can try and make some trig videos a little more in depth, kind of going back to the beginning, or probably a better idea would be go to like Khan Academy. I'm sure he explains it a million times better than me anyway, or any number of people on the internet, on YouTube. I'm sure do a great job explaining trig, so I would definitely tell you that you should look at some of those because it is going to be something that you need to complete this chapter. Anyway, so just real quickly, I think the idea behind trig essentially goes like this, that people realize that just like when you have a right triangle, we're doing a right triangle trig, by the way, this year. In integrated 3, you'll do more stuff with trig, but right now we're just doing simple right triangle trig. So if I have a right triangle and I know that this side is 3 and that this side is 5, I can use the Pythagorean theorem, 3 squared plus 4 squared equals 5 squared, to determine that. So what people realized was that these work in a certain ratio, which is to say, if I made this small triangle, it would have the exact same ratios as the big triangle. They're similarly shaped. So like if I called this side x and this side y, and this side right here is z, it would have the same ratio as if this big X and this big Y and this big Z. So when people realized that, they decided that, hey, if we just divide these sides by each other, we can figure out what the ratios are, and then we can use those. And then if we know what the ratios are, we can figure out the angles and vice versa. So we can figure out a lot about a triangle, a right triangle, just sort of by what is being shown to us on it. So that's the concept that we're going to be looking at as we go into reviewing trig. I just wanted to kind of throw that out there to have you guys all remember that. And I know sometimes the second time you hear something, it sticks with you. Maybe the first time I went through that, it didn't make a lot of sense, and hopefully that time it did, if that's the case. Long story short, if I'm in the front of the classroom, my perspective is different than if I'm in the back of the classroom. If I'm in the front of the classroom, I'm looking at your faces. If I'm in the back of the classroom, I'm looking at the back of your heads. So same thing is true here. If I'm talking about the opposite side of 25, well, opposite the triangle, I go all the way across the triangle, this would be my opposite side. However, if I'm the angle C, the opposite goes over here. Now, the thing about trig is you can start from 25 or from C, it doesn't matter, but it is going to change the ratios that you set up. So just be aware of what you're working on. We're going to start at 25 for this example, so I know that if I go all the way across, this is going to be my opposite. My hypotenuse is actually the longest side, and it's across from the 90-degree angle. Hopefully you guys know that. They're actually telling me that my hypotenuse equals 7 in this problem. And then finally, the last thing is the adjacent. So it's known as the adjacent leg. So this is the opposite leg. This isn't a leg at all. It's the hypotenuse. It's not a leg. And this is the adjacent leg. So I have opposite leg, adjacent leg, and hypotenuse. Again, opposite should always be pretty easy to find. Hypotenuse should always be pretty easy to find. And the adjacent is the other one. So at this point, if I want to figure out what the O is, I have to decide, I need to know a few of these things here. I can use, let's see here. I know I want the O. I know that's important. I know I don't want the A yet, at least. That I know I don't know what it is, so that's not important. And I know what the H is, so that's important. So the O and the H are the two that kind of stand out here. The A I'm not trying to solve, and I don't know what it is, so it can't help me. The O I'm trying to solve. The H, I already know what it is, so this information might prove useful. So I'm going to use O and H. I go here, that's not O and H, that's not O and H, there's O and H. So I want the sine of 25 degrees. And the sine of 25 degrees is going to equal the opposite, which I don't know what it is, so I'll just call it O, over the H, which I know is 7. Now at this point, I'm really hoping my computer doesn't freeze up, because it does not seem to like when I do the next step here. What I'm going to try and do is go to the trig table. And I provided that in the folder, so if you don't have access to the trig table or a graphing calculator, you can find that, although quite frankly you can find it all over the internet. It is completely ubiquitous. But anyway, I want to show you how to use it. So I am going to go and I'm going to open up, and I want to know what the sine of 25 degrees is. So if I go here to the sine of 25 degrees, you can see sine, cosine, tangent. I'm working on sine. The sine of 25 is 0.4226. And like I said, essentially what they've done is they've divided the sides together and figured out that it's always 0.4226. It doesn't matter how big the triangle is. If you have a 25-degree angle, if you divide the opposite side by the hypotenuse, you always get that same ratio of 0.42226. I think I said one too many twos right there. So I'm going to go back to the other one, 0.4226. And I'm going to change this now, because I know that this is now 0.4226 equal to O over 7. I'm going to cross multiply to solve. I know that my O is going to be whatever 0.4226 times 7 is. And that's going to end up being, I have a calculator by the way, 2.96. So now I know that this O is equal to 2.96. So let's go ahead and let's solve for A. And there's a couple of ways I can solve for A now, because now I know an extra side. So I could use A and H, right? I want to know A, and I know the hypotenuse, so I could use the cosine of 25. That would be fine. Or I could use the O and the A. Again, I know the O, I want to know the A, and use the tangent. I'll tell you, I think most of you guys that understand this realize that the cosine would be easier because the A would be on top. That's why I'm going to choose the tangent, because I want to show you what happens when the variable's on bottom. It's not a big deal. You can still use it. So I'm going to use the tangent of 25 degrees is going to be equal to O, which is now 2.96, over A, which I don't know what that is. But I do know that I need to go back to my table, and I need to look at the tangent of 25 degrees to get that ratio. And again, what we're saying is every single right triangle in the universe, if you divide the opposite side by the adjacent side, you always get a ratio of 2.96, which is pretty crazy that someone was able to realize that. So let's see again if I can do this without freezing the computer. So I'm going to go here. I am going to go to the tangent of 25 degrees is 0.4663. By the way, I think I just lied to you. I said that the ratio is always 2.96. It's not I'm sorry. It's not 2.96. It's 0.4663. So I apologize. If you divide the opposite side by the adjacent side, you always get 0.4663. So disregard what I said a minute ago. I don't remember what I said now, but I think I said something wrong. So at this point, we're going to go back to the background, and I believe it was 0.4663. Hopefully I'm not misremembering that. So I'm going to go 0.4663 over 1 equals 2.96 over A. Again, shout out to A-Rod for figuring this out. J-Rod for giving me this ratio thing, because kids were getting screwed up solving this. So I'm going to cross multiply. I'm going to get 0.4663A equals 2.96. You can see it's a little bit different than what's going on over here. I just have an extra step to get that A by itself, a little bit of simple algebra. Hopefully we recall that. And we're going to divide 2.96 by 0.4663, and I'm going to get 6.35. The last little bit is this. I can also figure out what angle C is. Now, I think some of you guys realize, because the triangle angle sum theorem, that this triangle has to add up to 180 degrees. You realize that this has to be 65, right? 65 plus 25 is 90, plus 90 is 180. So we suspect this is 65 degrees, but I want to show you how you can get it using trig anyway. So I want to know what angle C is. Now, it's up to me if I want to use the it doesn't matter if I want to use sine, cosine, or tangent. It's eeny, meeny, miny, mo. We'll pick cosine. I haven't used it yet anyway. So we're going to say the cosine of C is going to be equal to, again, cosine is adjacent over hypotenuse. The adjacent is 6.35, and the hypotenuse is 7. So we're going to divide 6.35 by 7. We're going to get 0.9071. By the way, there's been a lot of rounding that's gone on here. So when I look, I don't expect to get exactly 65. I expect it to be super close, but not exact. So at this point now, again, all these ratios are the same. Anytime I have a triangle where my adjacent side, oh geez, I screwed this up. Hopefully you guys caught my error. You should have said something to me. Here's the problem. This is, if I'm looking from this perspective, this is now the O and this is now the A. I should have caught that earlier. Bummer. So hopefully you guys were like yelling at the screen, this is not right, Oliveira. You're screwing this up. So this is actually going to be, actually, it's probably not terrible that I screwed that up, because I mean, that was totally unintentional on my part, but hopefully it gave you the opportunity to say, like, this doesn't seem right. So 2.96 divided by 7 is going to give me a ratio of 0.4229. So again, now what I'm saying is, anytime we have a triangle where our adjacent side and the hypotenuse, the ratio ends up being 0.4229, I would expect the angle to be basically 65 degrees. So if you doubled this and made the hypotenuse 14 and this, 5.92, 5.92 divided by 14 would give me the same ratio, and I would have the same angle. If I cut this in half, and I had this at like 3.5 and I had this at like, I think 1.48, I could be wrong on that. Anyway, I would still get that same ratio of 0.4229. That's the way it always works. So let's go ahead and confirm that. Hopefully you don't freeze the computer at this point. So 0.4229 is what I'm looking for. And again, I'm looking at the cosine. So I'm going through the ratios, 0.4229. And you can see 0.4226 is the closest one, and there's our 65 degrees that we expected to see. So 0.4229, 0.4226, we can say, yeah, 65 degrees. We already knew that because of the triangle angle sum theorem, but it is pretty nice that trig confirmed it for us. Right, so we're going to go over here and we're going to say that indeed C is equal to 65 degrees. So that's just a review of trig. This video went longer than I expected, and I made a mistake on it. Luckily, we caught it partway through, so hopefully you caught that. If there's any questions, reach out to me. Have a great day.